Chapter 9, exercise set B. We do hypothesis testing here, and here is the first problem. The following observations were made on fracture toughness of base plate of 18% nickel Maraging scale. Do the sample statistics suggest that the mean modulus of rupture exceeds 75? We have 22 measurements, and using these 22 measurements you can find out the sample mean and sample standard deviation. They're here. Now let's set up the hypothesis. What is the null hypothesis? Mu0 value should not come from the sample, and it's right here, 75. So that's mu0. That's will give you the null hypothesis. How about the alternative hypothesis? Here is a keyword, exceed. Consequently, we have something like that. Another indicator, the mean is 77.33. That's bigger than 75. That's another indicator for mu is greater than 75 as an alternative hypothesis. Okay, now that the hypotheses are set up, let's go over to the testing, and let's do probability value method this time. If you prefer critical value approach, look at the previous video. We already talked about it. If you prefer the other methods, well, they are coming. In this video, we are talking about the probability value approach. Okay, sample statistics. Well, here they are, sample size of 22. Consequently, the degree of freedom is 21. Sample mean, sample standard deviation is there. Calculating S over square root of 22, you can find out the standard error. Alright, and let's draw a picture associated to the p-value approach. The key and shade part must reflect the p-value approach. And will be the x bar, as you see here. X bar 77.33, the observed mean, and the probability that exceeds x bar is my p-value. Here I'm using this p part as purple. Now, what is this p? This p is, as a matter of fact, a conditional probability that the sample mean ends up getting as big as 77.33 or more, assuming the null is right. It's a conditional probability. And if that probability is sufficiently large, then we are going to select the null hypothesis. Now, if that conditional probability is too small, then we are going to go with the alternative hypothesis. How large is large enough? How small is small? That's going to be your alpha. So calculate p, and then if p is greater than alpha, then we go with the null. P is less than alpha, then we go with alternative. A little bit confusing? Sorry, that's the nature of probability approach. Theoretically, the probability value approach, the p-value approach, is related to type 1 error and type 2 error. And p-value is basically the probability for type 1 error. And I want to minimize the type 1 error, and that's the theory behind the probability value approach. Still confused? I'm not really blaming you. Among all these methods, the p-value method is the hardest, the most difficult, and the most confusing one. I really do not understand why this one is preferred method of our textbook. Anyway, here it is. We're looking for this p-value. So how do you do that? Well, we have to find out appropriate t-score. Let me expand the font. And this is gonna be 77.33 minus 75.0 and minus center over standard error of 5.037 over square root of 22. And you can explicitly calculate that thing, and what do you get? Okay, that is your t-score associated to the observed mean of 73.33, or x minus, more precisely speaking, x bar minus mu 0 over SE. And because we have bar here, typically we use T bar as this quantity here, and T bar turned out to be 2.169 something. So using that, you have to find out the probability value here. How do you do that? One way is to use technology like this. I use Mathematica to do the computation, and turned out that probability is 0.02 something. And you can use statistical calculator too if you want to. And 0.02, that's less than 0.05. So we have to go with alternative hypothesis. Here's the conclusion, by the way. 0.02 is less than 0.05. So here in the conclusion, the previously purple part is now highlighted in red, indicating that the alternative hypothesis wins. This is the p-value approach, or the probability value approach. Now, what if you do not have any technology aid? How do you get this p-value out of this t-score or t-bar? This is how you do it. This is our textbook's t-table at Appendix B, page 719. And we have t-table like this, and we can find, let me see, is this the right one or is the next one the right? Okay, sorry, you have to look at page 720, and this is the t-table with p-value. And please be warned, this table is terrible. Okay, what is the t-score we had here? 2.17, and t-score for 2.17 should be here. Well, we don't have 2.17, so closest is 2.2, so that's where we have to settle, 2.2, and then the degree of freedom is 21, isn't it? So if we go over here, we get 0.020. Do you see here? Degree of freedom is 21, that column, and then 2.17 is approximately 2.2. So right here, 0.20, that is your p-value according to our table. And 0.20 is less than 0.05, the alpha value. Therefore, alternative wins, and we reject the null hypothesis. Anyway, if you like this method, please go ahead and use it. Personally, I do not like it, but after all, for a very strange reason, this is the preferred method of our textbook. And if you like that method, please go ahead and do that. Personally, I would like to discourage you and emphasize either critical value approach or hybrid approach, but if you prefer to use this, I'm not going to stop you.